G'day guys, I've got an implicit differentiation question for you today where I've got a expression or an equation which defines this particular curve that we see on our screens here. And we're asked to use implicit differentiation to obtain an expression for the derivative of y with respect to x. Now, just before we move on, guys, whenever I'm doing an implicit differentiation question, I always like to remind myself that in this equation that we see up here, y is always being thought of as an expression of a function of x. So whenever we do these implicit differentiation questions, it's always good to keep this particular relationship in our heads. Now, I'm going to keep referring back to it, but I thought I would just flag it right at the start. So let's get to the question. So like any implicit differentiation calculation, guys, what we're going to do is we're going to take the derivative with respect to x of both sides. So I'm going to have d dx of x cubed plus y cubed, and that's equal to the derivative with respect to x of 3xy plus y. Now, like any derivative, what we can do is take the derivative of each individual part of these expressions. So I can have d dx of x cubed plus d dx of y cubed is equal to d dx of 3xy plus d dx of y. Now, I'm aware, guys, that in an exam situation that we probably wouldn't do this step here. However, I do believe that by fully writing down what my thought processes are, it makes the video sort of more easy to understand for everybody. So from here, guys, what we're going to do is we're going to begin to compute the derivatives. d dx of x cubed, we're just using the power rule, so that's going to be equal to 3x squared plus. Now, the derivative with respect to x of y cubed. Now, we have to remember, guys, like I said before, that because y is a function of x, if I have a y cubed here, this is the same as saying a function of x cubed. So if I was to do the derivative of this, I could use the chain rule and do my outside function first, and I'd have 3f of x all squared times the derivative of like the function with respect to x. And that's how I'm going to write this particular part of this equation here. I'm going to say, well, the d dx of y cubed is equal to 3y squared times the derivative of y with respect to x. Now that's equal to d dx of 3xy. Now here, guys, we're going to use the product rule as well as the chain rule. So the first thing is with the product rule we're going to do is if we have 3xy, the derivative of this is going to be the derivative of the front function, which is 3x, with respect to x, which is just 3, times the back function, which is y, plus we leave the front constant, and then we take the derivative of y with respect to x, which in this case, like the one above, is times dy dx. So let's stick that in here. We have 3y plus 3x times dy dx. And then the last one is going to be the derivative of y with respect to x is simply dy dx. Now, what we usually will do, guys, with any of these particular implicit differentiation questions is we're going to try and get all of the components of the expression that contain dy dx to one side of the equality. So what I'm going to do is I'm going to take all of the dy dx's to the left. So I'm going to be left with 3y squared times dy dx minus 3x times dy dx minus simply dy dx. Now this is going to be equal to, I'm going to bring that 3x squared to the other side, and I'm going to have simply 3y minus 3x squared. Now what I can do from here, guys, is I'm going to factorize the left-hand side by dy dx. And then I'm going to be left with 3y squared minus 3x minus 1, which is going to be equal to 3y minus 3x squared. And then I can divide both sides by this factor, which is contained on the left-hand side. And I'm left with dy dx is equal to 3y minus 3x squared, all divided by 3y squared minus 3x minus 1, which could be rewritten as 3 bracket y minus x squared on 3y squared minus 3x minus 1. Great. Okay, so the question goes on to say that the slope of the curve at origin O and points A and B is equal to 0. So we have to show that the equation that determines the x coordinates for points A and B is given by this particular quartic function, and hence determine the coordinates for the points A correct to the third decimal place. Okay, so we've got our slope function here, and we're told that at the points A, B, and 0 that this slope function is equal to 0. So for this rational function here to be equal to 0, the numerator alone must equal 0. Because if the denominator equals 0, then the thing goes to infinity, or some people would say it's undefined. So for this to equal 0, what that implies is that 3 bracket y minus x squared has to equal 0, or y then would have to be equal to x squared. So now that we have this function, what we can do is we can substitute this particular relationship between y and x squared. Remember how we were being reminded that y was a function of x? So now we know what function of x defines these points or links the points A and B. So what we're going to do now, to find the x coordinates for points A and B, we have to then substitute the function which defines y in terms of x. So we're going to reintroduce our original function. X cubed plus y cubed is equal to 3xy plus y. So what we're going to be doing is inserting this particular relationship here into that function there. So let's get to it. We don't have to do anything with the x cubed. We have y equals x squared, and then that's being cubed, and that's equal to 3x times y, which is equal to x squared plus x squared. So let's multiply out the brackets, making sure that we don't make any silly mistakes. This is 2 to the power of 3, which is going to be x to the power of 6, equals 3x times x squared is 3x cubed plus x squared. Now let's get everything to the other side. So we have x to the power of 6, then x cubed minus 3x cubed is going to be negative 2x cubed. Then we have minus x squared equals 0. And then what we can do is factorize this by x squared. Now, the equation that's going to determine the coordinates for A and B is going to be this particular one in here. Now, the reason for that is because if we use our null factor law on this one, we can see that x squared is going to have to be equal to 0, or x to the power of 4 minus 2x minus 1 is going to have to be equal to 0. Now, for this particular equation here, x is going to be equal to 0. And we can see that that relationship defines the origin point. So A and B then are going to have to be defined by this particular expression. And now we have to determine the points A and B correct to 3 decimal places. So from here, guys, what I'm going to do is get this equation here, and I'm going to just use my graphics calculator to solve it. So I'm going to go solve x to the power of 4 minus 2x minus 1 equals 0, and I want you to solve it for x. And we have a couple of different solutions. Well, we have 2 different solutions. X is negative 0.47463, or x is going to be equal to 1.3953. Great, so now I have to just determine the coordinate for point A. Now we can see that for point x is less than 0. So as a result, we're going to be using this particular expression here. So what we're going to do is I have the x coordinate, not to the correct decimal places yet, but I'm going to use the more accurate x coordinate to find the y coordinate. We worked out that y was equal to x squared. So what I can do is I'm going to work out the y coordinate point by just going negative 0.47463 squared. Great. So from here, guys, now, sorry about my working out. It's a little bit all over the place. But from here, what we can say is, therefore, the coordinate for point A is going to be negative 0.475, and the y coordinate is 0.225.